All right. Most of you in geometry have talked about this. This is kind of the basic trigonometry you got in geometry. That sine of some angle, whatever it happens to be, what you do is you take the opposite of that angle and you divide it by the hypotenuse. And seeing the word hypotenuse is included means this is what type of triangle? Right triangle. Cosine is then the ratio of adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA is a good acronym for remembering it. But please, as I tell my geometry students, spell it correctly. I know it's not actually a word, but if you put them in the wrong order, it's not a very good memory device. All right, so it's sine because it's opposite over hypotenuse, cosine adjacent over hypotenuse, tangent opposite over adjacent. So I started you with a very straightforward one, although you may notice on mine there's a piece missing. I don't know if it's missing on yours. It is. That is a very straightforward one, and I hope that you know that one. With basically doing no work at all, it is 3. But let's say you didn't know what it was, you would use Pythagorean theorem, correct? The reason I want you to know that one is this is by far the most common Pythagorean triple. And its Pythagorean triple will work because it is a right triangle. It is 3, 4, 5, as long as 5 is the hypotenuse. All right. So if we're dealing with angle A, so we'll do all of these first. So here's angle A. Well, then obviously 4 is in the opposite position. Opposite that, 5 is the hypotenuse, 3 is adjacent. So sine says to do opposite over hypotenuse, so 4 over 5. And what I would like you to realize is really 4 over 5 could be written as a decimal, which happens to be 0.8, right? Huh. It's less than 1. That might prove to be important. Cosine of A. Cosine is adjacent over hypotenuse, so that'd be 3 over 5. Or 0.6. Once again, less than 1. I can guarantee you every time that the decimal form or even the fraction form will be less than 1, because let's face it, you're always dividing by hypotenuse, which is supposed to be the biggest side, right? And there is another reason that it will be less than 1, and we'll hopefully make that connection soon. Tangent really doesn't have to follow those rules because it's some version of opposite and adjacent, right? It could be the bigger one, could be the smaller one, who knows? But tangent of A here would be opposite, which is 4, over adjacent, which is 3, which is, well, we'll say 1.33, you get the idea, right? Any disagreements with angle A's sine, cosine, or tangent? Because you're going to have to know this stuff very well, because right now, as far as you know, there are only 3 trigonometric functions, sine, cosine, and tangent. There are 3 more that you will learn this year. So now to do angle C, what we're going to do is we're going to kind of erase this stuff like that, and we'll do C in green. So here's angle C, which makes, oops, that's 3. We should have kept that one, right? That's opposite now. What's 4 now? What's a word that could describe that? Adjacent, very good. And 5 is still hypotenuse, so that didn't change, right? So should sine or cosine over there for angle C, should they get bigger than 1? No, because you're still dividing by hypotenuse, right? So let's do sine of angle C, so it's opposite, which is 3 over 5, otherwise known as 0.6. Cosine of C is adjacent over hypotenuse, which is 4/5 or 0.8. And tangent of C is 3/4, otherwise known as 0.75. So as you can see, tangent sometimes is bigger than 1 and sometimes is not. It really doesn't have to follow that general rule. Okay. So that should have, hopefully, been review for some of you. That is very recent review, and for some of you that may have been a while since you've seen that. Okay, because we have a big difference in people that have had this. This one's different, basically for one main reason that the hypotenuse is missing this time. And here's where I have to make a huge distinction for those of you, I think there's actually only one of you doing geometry and this at the same time. In geometry, I kind of allow decimals a little bit more. In here, no. I need exact answers, right? And so you have to, I don't know, it's just a little bit more specific in here. So we have to go find AB. Unfortunately, 8, 12 blank isn't a Pythagorean triple. At least not a nice one. Obviously, there is a third side, but we don't know what it is. So we do have to do Pythagorean on that one. So remember, Pythagorean is, and remember this only works for right triangles. And so which one am I missing here, A, B, or C? I'm missing C, right, the hypotenuse? So we don't know that one. Does it matter 8 and 12, which one's A or B or anything like that? No, not really, right? So 8 squared plus 12 squared. So what do we got there, 64? Anybody know 12 squared off the top of their head? 144, good. Equals C squared. If we add that, what's that, 208? So that side's 208? That doesn't make any sense. Yeah, we got to take square root, right? Now, is 208 what's called a perfect square? Is that something that I hit the square root button on my calculator and it gives you a nice whole number? No, it doesn't, does it? Now, here's the case. In geometry, I would say, oh, just go ahead and get the decimal close enough. Nope, not in here. We have to simplify that. Okay? Which means we have to break it down. So 208, what number would you guess goes in there? Ooh, 16. Who said that? That's a good guess. Nice. 16 and what? And somebody up 13? Now remember, all you have to do is try numbers. What's the first perfect square is? 4. If 4 goes in there, and maybe you try 9, maybe you try 16, 25. You try all those numbers. So what is the, remember, if I multiply these, do I actually get 208? Yeah, so is that really saying the same thing? Yeah, just differently. And square root of 16 is 4. Do we know the square root of 13, or does that break down any more in a useful way? I could do 1 and 13, but that doesn't really help, right? And let's face it, 13's prime, so hopefully you knew that. So 4 square root of 13 is right there. Don't forget the 1 when you do it. Yeah, I got to write that again. So any questions how we got the third side of our triangle? It's not the only way you could have done it. In fact, you'll learn some other ways as we go through this chapter, but that right there is one way. Everybody good with that? And 4 square root of 13 is exact. There's no guessing about that. Okay, can I erase the Pythagorean theorem then? Because I'm going to kind of need the workspace. Everybody's good? I figured so. Yeah, it actually worked too. All right. So now let's talk about A. So let's just do this top row, do all angle A first. 8 would be called, of course, opposite. 12 is adjacent. And this one over here we just found is hypotenuse. I'm just hoping, I keep writing it, I'm hoping the more you see it, the better chance there is that you actually spell it right. Okay? So if we want sine of A, we have to take opposite, which is 8, over hypotenuse, which is 4 square root of 13. Unfortunately, that is unacceptable. You have a radical in the denominator. And as far as advanced math goes, that is unacceptable. So the first thing I would do here, you don't have to do this, but this 8 and this 4 do simplify. Right? 4 goes in there once, 4 goes in there twice. So we're really looking at 2 over the square root of 13, correct? That makes it a little more acceptable, but still not completely acceptable because of that radical. So we have to multiply by something that will change the appearance of this, but not change the value. So there's only one number I can multiply by, and that is 1. I can multiply by any form of 1 I want, and that won't change the value, but it might change the appearance. So do you think multiplying by 2 over 2, is that going to help here? Not really, right? We're going to multiply what's called the conjugate here because it'll take care of business. And who knows what the conjugate is for this one? Yeah. Very good. Square root of 13 over square root of 13. Again, I call it, when I had some of you for Algebra 2, the funny form of 1. Okay, and I don't know if that's what it's called with the other teacher or not. So what happens here is your numerator becomes 2 square root of 13. Well, why would we choose square root of 13? What's so significant about that? Well, you're taking it times itself, right? So you're really squaring it and square rooting it, so they kind of wash, right? Or you could say it's the square root of 169, which is 13, right? Either way, but it ends up like that. So in here, I'm much more picky. Okay, that's the answer for that one. Now, don't think just because there's a radical in it that they're all going to be all this hard and you have to do all this conjugate. So maybe in red we will do cosine of A so that you can see the work there, and I'll leave it up there for you. Cosine of A, according to SOHCAHTOA, that's supposed to take adjacent over hypotenuse, right? Adjacent is 12. Hypotenuse is unfortunately 4 squared root of 13 again, right? But very nicely, this one does simplify first. And just let me know if I'm going too fast. Okay. So the 12 over 4 does take care of itself. 4 goes in there once, goes in there 3 times. So we have 3 over square root of 13, right? So once again, radical in the bottom, unacceptable. And the only number we can actually multiply by without changing value is 1. And so we choose square root of 13 over the square root of 13 because it's the easiest one to choose, although it really looks weird. And so we get 3 square root of 13 over 13. So any questions where we've gotten sine or cosine yet? No? Will tangent be as hard? No, because there's no what? No radical involved with tangent in this one, right? So here's angle A. We need, according to that little code up there, opposite over adjacent, which is 8 over 12. Is 8 over 12 going to be acceptable? Nope. Got to take care of that. What comes out of both the 8 and the 12? 4, so we're left with 2/3. All right? Any questions? Everybody good? All right. Because of some of the stuff that's happening at the end, let's just go do these real quick. Cosine of B. I'm going to take a real wild guess on this one. Yeah. Because sine of A and cosine of B better be the same thing as long as they're the other angles. Because which angle did I not ask anything about? In this case, it's not always C, but it happened to be the right angle, right? I don't ask a whole lot about that because opposite and hypotenuse are the same side. So how do you know what's what? All right, and I'm just going to take a wild guess on this one too. I'm just doing things for sake of time. If you need to see these done, you can stop on in. I'll definitely help you with that. And I'll take a wild guess on tangent. So are there any questions so far? That's the nice thing. If you're asked a lot about the same triangle, once you do it once, you don't have to necessarily go through all the work again. Be good? All right. Well, why do you suppose we've done this already, haven't we? Why would you suppose I would bring this up again? It's not hard. Sine of 43 degrees. Does my calculator know what that is? Yes. Okay. But what do you have to be very careful on when you start using a calculator? Now this probably makes more sense than it did in geometry. In geometry, I always told you to be in what mode? Degrees, because in geometry it was always degrees. Well, here it's degrees, radians, who knows, right? So letter A, we obviously know it's degrees because the degree symbol. Well, let's give it a shot. Sine of 43, huh? All right. So when you're on one of these, the place to check is hit mode. And as you can see, I am actually in degrees. It is the third option down. If you have one of those other calculators, what are they called? TI-30X2S's or whatever they call those things. It should be a little D or a DEG, I think, on your screen. Okay. And to change it, I think you hit the DRG button or something like that. The DRG button actually stands for degrees, radians, or gradient, whichever one you want. And that's what that stands for. All right. Everybody good? Everybody knows which one they're in? And I think somebody was saying the iPads, if you turn them sideways or something, you get to have all the trig stuff. I don't know. All right. So sine of 43. Sine 43. Do I have to put the degree symbol in there? No, because I'm telling my calculator I'm going to give you it in degrees, and so there it is. Some decimal. And remember, earlier, we had sine and stuff, and they were decimals. It's just we wrote them in fraction form. So what do I say, nearest 10,000? So 0.6820, I guess, right, if you had to round that. So 0.6820. And the next one, cosine of 84. You just go ahead, you type in cosine 84, no big deal. Again, I didn't have to do anything because I'm already in degrees. And so what I'd like you to do, if you have a calculator with you, make sure that you have these two answers coming out correctly so that there's no calculator issues. So it's 0.1045. What I find very interesting that you might be a little nervous about is that the angle got bigger, but cosine was actually smaller than when sine was there. That's kind of weird. That'll make sense as we go further. So obviously, could I change pi over 2 to 90 degrees and just do it that way? You could, right? But let's actually practice with the radians. So we got to go here. We got to go to mode. And for this one, I just go down like that. And radians is blinking now and hit enter. Now I'm in radians. For those of you with those other ones, I think it is the DRG button you have to hit. It gives you the option of degrees, radians, or gradient. And you just choose radians at this time. And now all you do is you go sine. And all you have to do simply is, in pi on this one is above the caret key. Just type in pi over 2. And it knows that that's radians because you told it it's radians. Ooh, exactly one. And that is actually going to be one of them you can do by hand without a calculator very soon. There's going to be a lot of them you'll be able to do very soon without a calculator. And then we got to do cosine of pi over 7. All right, cosine pi over 7. Yeah, this is a little refresher there. Wait a minute, cosine, the angle actually got smaller and the value got bigger. That's weird. But it's 0.900, well, actually 0.9010, right? Okay. There is a decimal point there underneath those arrows. Any questions on those? That's not too hard, right? Let's just type it into a calculator. All right. Here's where the interesting stuff begins. Determine the values for sine and cosine of an angle in standard position. Standard position, remember, is that positive x-axis on the unit circle. With measure theta. Again, that's just saying the angle is theta. If the point 3, 4 is on the terminal side. So 3, 4 is where it ends. Here's how I do these. It's quite simple, actually. I start by drawing an xy axis. I like to draw pictures. I'm not very good at it, but I like to draw them anyway. And put 3, 4 on there. So 1, 2, 3, 1, 2, 3, 4. There it is. Kinda. Yeah, pretty close. Now remember, this positive x-axis, the one going this way over here, that's your start of your standard position, right? So basically it goes from here, the angle then goes up there. So it starts here, along here, and then goes up to that spot. That's where theta is. That's the actual angle. For example, on the unit circle, maybe that was 45 degrees or 30 degrees or 60 degrees. It could be any degree, but that's where kind of as a reference for you. So based on that, I'm supposed to get sine and cosine. That seems kind of hard, but it's not. Here's something you might want to write off to the side. Whenever you have a problem like this, always connect your point to the x-axis. Don't connect it to the y, connect it to the x. And once you write that down, I'll show you what that means. Maybe you can draw an arrow to this when you draw this segment in. I'll give you a second to write that down. Do you have a point 3, 4 on my paper? Connect 3, 4 to the x-axis. Straight and as quickly as you can, which means go from the point and go straight down. Do you now see a right triangle? Yeah, you do, don't you? Do you know any information about that right triangle? I know that angle right there, and theta is always going to be over by the origin when you do these. See how theta is right there? I'm going to make this triangle bigger because for some reason I made it really, really small. Do I know anything else about this triangle? Yeah. Right. We know that this bottom one, how far did I go? I went 1, 2, 3, right? So the bottom one's 3. This one on the right is, well, how do we know that? We went up 4. Now, I was told it was a 3, 4, 5 triangle. Obviously, we're very smart. That's why we know that, right? But not all of them are going to be triples, but a lot of them are. Okay, because I'm more concerned about the sine and cosine stuff right now than you sitting there doing Pythagorean theorem all day, right? So it's 3 there, 4 there. Is it actually 5? Yes, it is. So here's your right angle. Can you now tell me a whole lot of information about theta? Yeah, can you tell me sine? Can you tell me cosine? In fact, you could tell me tangent if I really wanted to know, right? But it doesn't ask. Let's just do it. So sine of theta equals cosine of theta equals. So according to my picture, sine of theta, remember, once again, this is me trying to have you see it as many times as possible. If I'm doing sine, I got to do opposite over hypotenuse if I want to do that one. And if I'm talking about that angle right there, opposite is 4 and hypotenuse is 5. So 4/5, again, remember that's really like 0.8, right? Kind of like the decimal we got from the calculator. And then cosine is, according to this, down here, adjacent over hypotenuse. And this one must be adjacent then down there. And so it's 3/5. Otherwise known as, again, 0.6. And that's it. And that's about all the more complicated that can get. The idea is getting the picture. Once you got the picture, it's not that hard. Okay. Let's try a couple more just to make sure. Is everybody done with this one? Can I hit the arrow? All right. So here it says determines, ooh, this is different. Determine sine when cosine equals 5/13 and the terminal side of theta is in the first quadrant. Well, probably a good idea would be to start with. Maybe I'll make it bigger this time. How about that? That way maybe you can see it. Did it tell me exactly where the terminal side was? It kind of did, but it's just a picture, right? Do I care if it's 100% like right on the money? No, not really. So here's what I would do. Say, all right, I know this is standard position, and I know it's supposed to end in which quadrant? So just throw something out there. Looks good. Wherever you want. Be creative, but make it straight. Don't draw squiggles or something. And so we'll say that's kind of our endpoint there. And what was that little note I told you to write down? Connect it to the x-axis. So here we are, connect it. Well, maybe don't go as far as I did, but you get the idea. Where's theta again? I kind of told you where that should, by the origin, right? So in your triangle, but closer to the, so is it number 1, number 2, or number 3? Where does theta go? Spot 1, very good. Well, now I erased my triangle, but that's all right. Theta goes right there. Well, this is tricky. You got to think backwards and then forwards again, and it's kind of weird. So it says cosine of that angle is 5/13. So do you know exactly where 5 and 13 should go? Do we? Yeah, we should. Because that tells me exactly where to put it. Cosine is adjacent over hypotenuse. So which of these numbers up here is adjacent, 5 or the 13? The 5 is adjacent. The 13 is hypotenuse. Well, the hypotenuse of this thing's right there, 13. So the 5 only has 2 spots to go. It either goes into spot 1 or spot 2. Where should the 5 go? Spot 1, that's the adjacent, right? And what is it again, a 5? Now, does anybody know this triple? Yes. 5, 12, 13, very good. And that's if the 13's the hypotenuse. All right. And so, yes, it is 12. How would you figure it out if you didn't know? Pythagorean theorem. But you might want to know 3, 4, 5, and 5, 12, 13, 2 of the most commonly used. All right. Well, now what? That's a great picture. Oh, got to do sine. Oh, that's right. Determine sine. All right. So sine of theta, is that something I can even determine at this point? Well, now that I have the picture, yeah, it's not that hard, right? Here's theta, and that one over there is opposite. Hypotenuse and adjacent, oh, it's 12/13. Any questions so far? What's weird about the next one? Yeah, negative. Ooh, what's that all about? All right. Everybody ready? Again, tell me if I'm going too fast. All right, it's saying determine sine when cosine is negative. Well, think about your unit circle. Did we have some negatives on there? Where were, there's a lot of ways to do that. But let's think about that. Just watch up here for a second or two, and see what happens. So does it really tell me which quadrant to put it in? No, so let's try a few spots and see what happens. So don't write this down yet. What if I try it over here? If I do theta and do adjacent over hypotenuse, right? That's what cosine is. Is that fraction ever going to be negative if I'm in the first quadrant? Is that ever going to? No, because that's a positive going that way. And one thing you should know is hypotenuse is always positive. It's a distance. Hypotenuse will never be negative. Might want to write that up to the side too somewhere. So quadrant run, is that a possibility? That's a big no. Oh, well, how about over here? Ooh, that's different. But notice, what did I do? I put it in the second quadrant, and then what was my first move? I connected it to the x-axis. Now, who can tell me where theta is on this one? 1 dot, 2 dots, or 3 dots? 1 dot, exactly, it's always right there. Theta. So this is adjacent and hypotenuse. Does that have a chance of being negative? It does, doesn't it? So that could be where it is. So let's use that one. And I'll draw it over here. So this one's what? Adjacent down here, hypotenuse, opposite. So cosine is negative 8 over 17. So negative 8, 17, right? Again, remember, hypotenuse is always going to be positive. It's a distance. So I have to find sine, which means I need to find opposite. This is actually another triple, less commonly known. It is 15. Very good. It's 8, 15, 17. So how come the negative doesn't play a role in that? Because what do you do to it in Pythagorean theorem? Square it, right? Which gets rid of negatives. So 8, 15, 17 is another triple to know. You can see how I'm trying to get you the most commonly one used now so that you just have them. So sine of theta, is that something I can now calculate? Yeah, it's 15 over 17. And here's what I'm going to tell you now. That's almost 100% correct. There is another answer to this problem. And for tomorrow, if you can find that other answer, I will give you extra credit. It's not as hard as you would think. But you do have to think a little bit to get it. Okay? So, extra credit tomorrow if you can come up with another possible solution to this problem. Any questions other than what the other solution to this problem is? You just have to think a little bit. Well done.